Alright, simplifying fractions. So, just like normal fractions can be simplified, like 4 over 8 is 1 over 2, fractions with variables can be simplified as well. Now, sometimes they're fairly straightforward, like in this case, if you have a monomial, both in the top and the bottom, then you can just simplify top to bottom. So 4 over 8, well, that's 1 over 2. A squared and an A, so 1 goes away, it leaves you 1. So that's 1A over 2, and that looks better as A over 2. Well, you can't do that here. In terms of, you can't say, well, I'm going to cancel these out, and I'm going to cancel those out, and then we'll take the whatever's left over and compare it. And if you don't really see why, let me try to show that maybe with some numbers. So let's say that I have 2 plus 5 divided by 6 plus 20. So if I can go sort of top to bottom, then 2 over 6 is 1 over 3. And 5 over 20 is 1 over 4, because both have a 5, so 20 divided by 5 is 4. So then this would be 2 over 7. And yet, if you do it the right way, you know that 2 plus 5 needs to be added first, and then 6 plus 20 is next, and it's not 2 over 7. Okay, so it doesn't work. So what you have to do is factor both the top and the bottom, and then hopefully there's stuff that's in common. So I'm going to start with actually looking at this and seeing what can I do there. Well, 4 and 8 have a 4 in common. X squared and x, so that x is in common. So what is left? 4 divided by 4 is 1. 1x is gone, leaves you with 1x here. Subtract. 8 divided by 4 is 2, and the x is gone. Do the same thing in the bottom. 16 and 20 have a 4 in common, so 4. 3x is 1x, so x comes out. That leaves you with 16 divided by 4 is 4. 3 x's. I took one of them over there, so that's an x squared. Minus 20 divided by 4 is 5. And the x is gone, so that's it. Now you can cancel, and that leaves you with x minus 2 over 4x squared minus 5. Okay. The reason you can cancel at this point is because now you have a product. And when you have a product, it's no different really than here, because the reason we were able to cancel here is because I had multiple products, several products, and 8 was 4 times 2 times 8. So common factors cancel out, leaving you with A over 2. So write a product first, then you can continue. Trinomials can be factored as well. The more you do them, the better you get. So that one is x plus 6, x minus 3. So let's check. 6 and a negative 3 is 3. 6 times a negative 3 is, so that's good. Now once you get 1, so in this case we got something in the top, see if you can use this a little bit for in the bottom. So for example here it says x squared plus 16x plus 16. I think your notes say 10. I messed up, that needs to be a 16. So x plus 6 or x plus 10 is, or sorry, x plus 6 is probably one of the factors here. It has to, this one have, sorry, in the bottom we have two positive factors. So 60 divided by 6 is 10. So if something works here, it's probably this. Cancel. Cancel, and then you get x minus 3 over x plus 10. And that's how you simplify fractions. So one question that I often get then is, so how do you know when to simplify and what you're supposed to look for? Well, you're not going to like my answer there. Probably not. It's just experience. The more you do it, the better you get at it. You start seeing patterns. And once you start seeing the patterns, it becomes a lot easier. So, will you get stuck? Sometimes yes. And then, you just try again. Wait for a while and come back to it. This can also be combined with multiplying and dividing fractions. Keep in mind that multiplying and dividing is basically the same thing, with a slight twist. So multiplying, you can just go straight across, right? So here, 2 over 7 times 3 over 4, we can do 2 times 3 is 6, 7 times 4 is 28, and then both have a 2 in common, so that's 3 over 14. Now, we could have taken that 2 out probably over here, because 4 and 2 sort of, you can cross cancel. I don't really like to use that term, but that's what you guys do. So both of these are divisible by 2, so that leaves you with a 1, and 4 divided by 2 is 2. and you get 3 over 14 right away. Okay. When you divide, keep in mind that you're going to end up multiplying here. So with division, what you do with the second fraction is you don't ask why, just flip and multiply. So we're going to use the reciprocal there. So it's 4 over 7. And now, when you multiply straight across, you can check for cancellations, but 2 and 7, nothing in common. 2 and 3, no. So no. So here you get 8 over 21. You can do the same thing with variables and fractions, but you do have to think about the denominator a little bit. Okay, so let's think about that first. So why is the denominator important? Well, if I look at this one over here, 2 over 5x, okay, this fraction will work for a ton of numbers, except not for one. If I made x equal to 0, you get 2 over 5 times 0, and you get 2 over 0. And a couple days ago we talked about that dividing by 0 is undefined. And one of the reasons for that is that, it just doesn't work the other way around. So, like if you did 8 divided by 4 is 2, you should be able to go 2 times 4 is 8. And when you do that with 2 over 0, and I'm not sure what that is, but whatever that is, when you multiply by 0, you should be able to get 2. And we talked about that. Well, that doesn't happen. There's nothing here that you can do. Okay? Alright, so I think I need this to be clean in a little bit. Alright, so let's multiply. Especially on these, before you multiply, look for factoring both in the top and the bottom. So here, 5x and 10, well, they both have a 5. So take it out. That leaves you with an x plus 2 times, over. And then here, x squared plus 5x plus 6. So two numbers that multiply to 6, 2 and 3, they add to 5. So we get x plus 2 and x plus 3. Okay. Times 2 over 5x. So now let's see what we have. X plus 2 and x plus 2 cancel each other out. 5 divided by 5 is 1, so that cancels each other out. So what do I have? Well, on the top I just get a 2, and then keep in mind that this all leaves 1s, so that's 2 times 1 is 1, or is 2. And in the bottom I have an x and an x plus 3, so you get x times x plus 3. Okay, so those two things are the same. However, we do have to note here that this product here, okay, is going to be equal to this product over here, but we do have to exclude all of the numbers that don't work here. So these two are the same, except for, let's see, what can I not use here? So if I'm looking at the bottom here, so this one we can't have x be 0, and here x plus 3 couldn't be 0, so we can't have x equal be a negative 3. Well, that one is here as well, and that one's here as well. What about this one? What about the x plus 2? In the original form of that, x plus 2 cannot be equal to 0, because if you did that, you would get, I think you would get a 0 over here. We'll check that out. So, let's see. I'm saying that you can't plug in a negative 2. If you plug in a negative 2 over here, you would get a negative 2 squared plus 5 times a negative 2. Sorry, that's messy. 5 times a negative 2 plus 6. So that's a negative 4. Sorry, it's a positive 4. That's 4 minus 10 plus 6, and that's 0. So you can't plug that in here, and you have to exclude it. So you can only say that this blue fraction is this red fraction for all x except x can't equal a negative 2, is then what you have to add. Because these other exclusions are still part of these, we don't have to list because they're still part of that one as well. So how does it work here? Well, you can either factor first and then flip, or flip and then factor, but at some point you need to factor. So let's see, what do we have? X minus 2 times x plus 1 over there. Keep in mind there's a 1 there. There's a pattern. That's x minus 2 times x plus 2. And I'm actually going to flip first. That's x squared plus 2x. And that's x squared plus x. So now I can call it a multiplication problem. And let's see what we have. So x squared and 2x have an x in common. That leaves you with a 2 there. And x squared plus x also have an x in common. That leaves you with an x plus, if you take the x away, x divided by x is 1. Don't forget that one. It's important. Okay. So what can we cancel? Well, let's see. X minus 2 and x minus 2. X plus 1 and x plus 1. X plus 2 and x plus 2. And then these x's cancel each other out as well. So everything cancels. So that leaves a 1. Not 0, that's 1. So the original expression, which is way over here, the original expression is equal to 1, but we do have to list all those x's that would give me zeros in the bottom, in the denominator. So x minus 2, so x minus 2 can't equal 0, x plus 2 can't equal 0, x can't equal 0, and x plus 1 cannot equal 0. And then usually we solve that, so you could just say x cannot equal, so if you add 2, can equal 2, subtract 2 for that one, so that's a negative 2, then 0, and then a negative 1. And then that's it. Okay. Right, last part, what about adding and subtracting? Well, for adding and subtracting, you need common denominators, right? And it's the same thing with variables. So that has an x minus 3 in the bottom, and you need to think of these as factors, so it might be good to put them in brackets, and that one has an x squared. So the common denominator here is going to be x squared times x minus 3. Okay, so that's the common denominator. So how do I use this? Well, the x minus 3 I have, but I'm still missing the x squared in this one. So I need to multiply this one by x squared over x squared. And this one has the x squared, but not the x minus 3. So I need to multiply this one by x minus 3 and x minus 3. And then you just multiply things out and see where you are. So x squared times x is x cubed, plus x squared times 2 is 2x squared, divided by, and in the bottom you don't, I guess, you don't have to multiply it out in the bottom. I'll try to tell you in a moment why I am trying to do it in the top. So 2x minus 6, and then we get another x squared over x minus 3. Same denominator, so now I can put it over 1. Big happy fraction. And the reason I multiplied it out is to see if there's anything that adds in terms of being like terms. But in this case, we actually don't. So we get x cubed plus 2x squared plus 2x minus 6. So there's nothing to do there. Sometimes you do, and sometimes you don't have things that you need to add or subtract. Okay, well, how about here? Well, you could do the same thing. You could just use x squared minus 4 over here and x squared minus, so x squared minus 4, we could use it over here, and then the x squared minus 1, we could use it over there. Okay, but it usually makes sense in these problems to factor first, because what if there's some stuff maybe that we can get rid of? So x squared minus 4, for example, is x plus 2 times x minus 2. And notice that that means that we're going to cancel these. And then here we're going to subtract, and in the bottom you get x squared minus 1. Well, that's x plus 1 times x minus 1. And what do you get in the top? So a 3 and a 2. 2 times 1 is 2, so that's actually x plus 2, x plus 1. So these cancel over here. So instead of trying to add those difficult fractions, you can add these fractions, and they're a lot easier to work with. Now I only need an x minus 2 here. Make sure I multiply it by both parts. And I need an x minus 1 over here. Okay, and then that should work. So x minus 1 times 1, that's just x minus 1. Minus. X plus 2, x minus 2. So I need to FOIL that. And in the bottom I get x minus 1 times x minus 2. Okay. Because I know I'm going to add this stuff anyway, and I'm going to get one denominator, I usually just start adding them at this point. So x plus 2 times x minus 2 is a pattern. That is x squared minus 4. Okay, looks like a negative there. And then now, if you think of that as being a negative 1, you can distribute that. So I get x minus 1 minus x squared plus 4. And then here we see one reason that we do multiply out in the top, but maybe not in the bottom. And that's because in the bottom, we just have a product. But in the top, we're going to do x minus 1 plus 4. So that actually can be an x plus 3 minus x squared. Okay, one problem left. Oh my, now we have 3 of them. So this is going to be forever. But maybe we're lucky and some of this stuff will cancel out. So x squared minus 4. And I think I started by saying when we start with factoring, you see patterns a lot. So that's x minus 2 and x plus 2. Plus x squared over x minus 2. Minus x cubed plus x minus 4. Well, that doesn't seem to factor, does it? Well, maybe that was supposed to be an x squared. I don't think so. We'll just pretend that it says what it's supposed to say. And then the bottom, again, is x minus 2 and x plus 2. Okay. Yeah, not too much. That one is gone. And that's an x squared. And then we're subtracting. And I'm just rewriting so that I can organize this sort in my brain and see what's going on. Okay, common denominator. So the common denominator here, I need an x minus 2 and an x plus 2. Well, this one has an x plus 2, so I just need this one. I need the x minus 2 over here. So I'm going to do x minus 2 times 1 plus. Here I have an x minus 2. Well, that's great. But I also need an x plus 2. So I need to multiply by x plus 2 in the top. So I can just do this. And then on the last one, I'm sort of fortunate if, or not sort of fortunate, but if that is the common denominator and you have both, you don't have to change the top. But if you're going to put these in the one or in one fraction, then you do need to worry about this negative, because this negative is going to distribute. Okay? So now I've got to distribute all these. So 1 times x minus 2 is x minus 2 plus x squared times x is x cubed. X squared times 2 is 2x squared minus x cubed minus x plus 4. All this divided by x minus 2 and x plus 2. And now I need to add and subtract some stuff that belongs together. So the x cubes cancel each other out. That's great. And then let's see. 2x squared. I don't have any other x squareds. So that one's gone. And then it's x minus x. Well, that one's gone then. X minus x is 0. And then a negative 2 plus 4. And that would be plus 2. Divided by x minus 2, x plus 2. Okay. And you can leave it like this. We do have a 2 in the top, that's common. And then that's as far as we have to go. I do want to point out that sometimes students get this one a little mixed up. That's an x squared plus 1. That is not a pattern. That's not x squared minus 1. So x squared plus 1 does not factor. So, okay. I hope this makes sense. Thanks.